Bonjour and good morning. Welcome to WASA Distance Education Center and PLAR Science. It's week 6, and this is the last week of classes for this week before we head out for our break. So we have two classes this week, one today on the 16th, and then we have one more class on the 19th, and then we will be here until Friday, December 20th, and we will not be returning until week 7, which will be January 6th, so Monday, January 6th, 2025. All students are welcome to join the radio Zoom classes. If you don't have the link for the radio Zoom classes, please let us know. You can also contact your local DEC. Mary is our PLAR counselor. Michelle is our senior courses, and the other non-PLAR courses, she looks after those students who may want to register for independent learning or IL courses. So if it's for PLAR, you can contact Mary, or if it's not PLAR, then contact Michelle. So remember, you can register for IL courses at any time during the school year, but you have to complete the course on or before June 13th, 2025. As I mentioned, it is week 6, so we will be looking or continuing with our lesson 3 chemistry. And we will also continue to hold 2 student draws. So keep those lessons coming, or key questions. One for students who earn a credit. That means if you complete a course or if you complete a culminating, then your name will be added to the draw. And then one for those who submit work. So if you are submitting for multiple courses, for example, PLAR Math, PLAR Science, PLAR History, then your name will go multiple times, depending on how many courses you're submitting for. And the draw for that will be at the end of the term. So it'll be at the end of term 1B. If you're needing help, so for this week, if you're working on your key questions or you're working on your culminating, make sure that you contact your teacher if you're needing any help. My email is there on each of the cover pages, my Facebook Messenger. So if you have any questions about the culminating or the key questions, my office hours schedule is available from your DEC, or you can contact me directly, and you may also call me at home. Once you're ready to submit your key questions or your culminating, you can either ask your DEC to fax it for you, or you can email it to studentwork@nnec.on.ca. Make sure you CC it to the teacher that's marking your work. So if it's PLAR English and Math, make sure you CC it to bosmond@nnec.on.ca. And if it's history, geography, or science, make sure that you include my email so that I know you have sent something to student work. You can also do it yourself by using your Notes app to scan email. You can send a picture of it through Messenger, or if you're within the Sioux Lookout area this week, maybe you're out shopping for Christmas gifts, then you can drop it off at our WASA office. We still have the outdoor mailbox on the side entrance, or you can knock on our door and we will let you in. If you want to work on your key questions over the holidays, feel free to do so. You can access our classes still on our WASA Distance Education Center YouTube. Make sure you subscribe so that if there are new videos being uploaded, then you will get a notification. So you simply go to our YouTube channel, and then you can choose which playlist you want to listen to. So if you're working on the PLAR Science, there's a PLAR Science playlist. If you're working on your grade 12 English ENG 4E, there's also a playlist for that. So these are for the term 1A Term 1A and 1B classes. So that's what's been uploaded there. So as we get to 2A, that will be there, and then to 2B, that will also be there. So we'll have a collection of all the classes for this year on that YouTube channel. So be sure to subscribe. And if you don't want to go to on that route, you can still ask for a request or ask for a USB of classes. We'll just download the classes on a flash drive for you, and then you can click, open the lesson, or listen or view the classes. So all you need, if you have a flash drive, you just need a USB port to play the classes. Students, if you're having problems with your email, or if you're unable to get in there, or if you forget your password, please make sure that you contact the office. If you're a PLAR student, you can contact me. I can reset it, and I can also activate your email if you'd like. Sometimes you may just need to sign out of all of your accounts if you're having problems trying to get in there. So students who are just joining us, we do have some students who were just signed up for the IL courses. Remember, you have an option if you're in the PLAR program. You can complete the key questions if you like from the lessons, or you can choose to take the culminating activity. So depending on how many culminating activities you need to do. So some people need to do all 5, so English, math, science, history, geography. Or if you might only have to do 1, so some people might just be needing their equivalent credit for English. So contact us if you're not sure if you should go with the key questions or if you should do the culminating activity. So PLAR students who choose the open book culminating activity, what we do is we email it to you or to the DEC. Remember that that supervision is not required, so you don't have to take it at the Learning Center. You can actually take it home and complete it. Successful students will receive their equivalent credits, and then you can go on to your senior PLAR and sign up for senior credits. If the culminating activity is not passed, meaning if you didn't get 50% and above, then the key questions in that particular subject must be completed, and the culminating activity can be retaken. Students are allowed to try several times to pass the culminating activity. And again, if you're not sure about doing the culminating instead of the key questions, you can ask Bonnie or myself for a sample test so you can review the format, so you can see what it looks like. If you already made your choice that you want to do the lessons and the key questions, so if you're doing the PLAR Science, make sure you have all 5 lessons. So for those students who just signed up for PLAR, make sure you have for lesson 1, astronomy, lesson 2 is biology, lesson 3 is chemistry, lesson 4 is physics, and lesson 5 is environmental science. So make sure you have all the lessons, and if you're missing any pages, make sure you contact the office. Okay, we got as far as key question 43 on Thursday. So lesson 3 chemistry, we got as far as here. For lesson 3, we have to go as far as key question 63. So that, besides lesson 1, lesson 3 had the highest number of key questions. There's 24 in lesson 3. There were 26 in lesson 1. Now, if you're doing the culminating, you will not receive a mark sheet like what I just showed you. This is the mark sheet that you will receive. So it just shows you that you have to answer questions for each section. So in this case, part A is chemistry, part B is biology, C is astronomy, D is physics, and part E is environmental science. Continuing with lesson 3, so if you turn to page 12 of your lesson book, we looked at properties of matter on page 12, and then on page 17, what are elements. Page 18 is the periodic table, and page 22 is what are compounds and molecules. Okay, so let's see how far we get with these topics today. So keep in mind learning goals. I can understand how matter is classified into pure substances and mixtures. I will explain the difference between a chemical reaction and physical change, and I can explain what happens in a chemical reaction. Okay, so quick review. We learned how matter is classified using a chart, and we said that matter can be divided into pure substances. So you can see the chart on the slide here. So matter, we said, can either be solid, liquid, or gas. So if it's a pure substance, it can still be subdivided or sorted into either elements or compounds. If it's a mixture, so if matter is a mixture, then that particular mixture can either be a heterogeneous mixture or it can be a homogeneous mixture. We also talked about different types of molecules. We looked at diatomic molecules, molecular compounds, and ionic compounds. Then on page 11, we studied a chart that showed the types of matter. And then, so what you have here for the types of matter, you have the white dot as an atom of one element. That means that's just one kind. And then another key there is a black dot, and that shows that that's an atom of a different element. So one's black, one's white. Then the following diagrams show you that if it's an element, you can have diatomic molecules. So diatomic molecules are made up of atoms of the same element. So in this case, you can have two white atoms. So this is also a diatomic molecule if you have two blue ones, but they're bonded. So remember, they're made up of two atoms of the same element. Molecular compounds are particles, but they are made up of the same number and type of atoms. So examples are water, salt, propane, caffeine, etc. In this case, by using our key, so the white atom and the black atom, so white and black pairs. So same number and same type. Mixture, this is where you have a mixture of two types of diatomic molecules. So an example would be carbon monoxide. So you get a pair of white ones and a pair of black ones. So they're mixed. And then another type of mixture is where you can have two different types of particles. You can have like pop or sandwich or rocks. Rocks, for example, is made up of mixtures of different rocks. So using our key, you have the white atom and the black atom. So you can have diatomic molecules, you can have compounds, and so on. Just like pizza toppings, for example, is a mixture. Then we looked on page 12, the physical properties of matter. And we said physical properties are characteristics that we can observe with our senses, like sight, touch, smell, hearing, or taste. And that's without changing the substance into something else. So one physical property could be size. It could be small, or it could be large, could be color. So it might be pink or blue, could be shape. So for example, is it rectangular or circular? Could be texture, is it rough or smooth? Could be sound, so it could be loud or quiet. Hardness could be soft or hard. Flavor, so it could be salty or sweet. Temperature, hot or cold. And there's other physical properties like mass or volume. And you can look those up on page 12. Okay, let's continue on to page 17. We said that you probably already know the names of some elements, so like gold, copper, iron, oxygen. Most elements are solids, but some are gases. There are only two elements, mercury and bromine, are liquids at room temperature. So here's an example of mercury. This is a thermometer. So the mercury is inside that glass case. So again, it's liquid at room temperature, and bromine as well is liquid at room temperature. About 25 of the 118 known elements are found in the human body. So again, this is a quick review. This means that roughly 21% of all elements are present in our body. Oxygen, carbon, hydrogen, and nitrogen. This makes up about 90% of our body. So if you look at picture on the right here, there's the head part. You have hydrogen is 10%, nitrogen 2.6, calcium 1.4, phosphorus 1.1, and others 1.0. Just shows you the percentages of various elements in the human body. Oxygen makes up 61%, carbon makes 23%. So these elements are essential because they help build and support our body structure and functions like breathing, energy, and growth. Turn to page 17. So on the bottom of page 17, the names of the elements can be written in symbol form. So symbols are just signs that stand for something else. So here are some symbols that you may know. So the first one is a dollar sign. That's the symbol for the dollar sign. Percent, the plus sign, okay, the number sign. So elements are represented by symbols, which are like short forms for their names. So here are the rules for writing symbols. The first one is the first letter of the symbol is always a capital letter. So think of it when you write your name, the first letter of your name is always a capital letter. Okay, so C for carbon. If there's a second letter, it is written in lowercase. So in this case, the symbol for helium is capital H, lowercase e. There's no period after the symbol unless it's at the end of a sentence. The symbols for chemical elements are universal, and that just means that they are the same no matter where you are in the world or what language is spoken. Okay, just the symbol, not the name of it. So it might be the symbol is C for carbon, let's say in Japan, but they probably don't say carbon the same way, but the symbol is still C. This shared language of chemistry allows scientists everywhere to communicate and understand each other easily. So basically, this keeps the language of chemistry the same for everyone to avoid confusion. Okay, turn to page 18 for the periodic table. So the periodic table, this was by a British scientist in 1913 Henry Moseley, he found a way to count the number of electrons in an atom using X-rays. So what he did then is that he then gave each element an atomic number based on how many electrons it has. So remember, an atom is made up of protons, neutrons, and electrons. So here's an example for oxygen. That's the element name. The element symbol is O. Okay, the atomic number is 8, and the atomic mass is 15.999. You don't have to memorize the periodic table, but we will look at some of the common elements. So on the following slide, you will see the periodic table of elements, and it will show you all the known elements, and it gives a lot of important information about them. As I said, each element is shown with a symbol. So no two elements have the same symbol. Again, that's to avoid confusion. These symbols are usually 1 or 2 letters. That means you won't see a symbol with 3 letters. So usually just 1 or 2. If there is 1 letter, like I said, it is a capital letter. There are 2 letters. The first is a capital letter and the second is lowercase. So examples: oxygen, symbol is O; carbon, symbol C; hydrogen is H; sulfur, it's S. So lithium is Li; helium, He; argon is Ar; and silicon is Si. The periodic table is divided into 2 main groups. They are either metals or nonmetals. So most of the elements are metals, which are found on the left side of the table. Nonmetals are on the right side. So there's a thick step-like line that separates the 2 groups. So I'll show that to you here. So when you're looking at this, you'll notice that many of the elements you might already know, but you probably didn't realize that these were elements. Like hydrogen, sodium is an element, calcium, carbon, neon, potassium, platinum, and tin. So you can see here the elements are arranged by increasing atomic number. Elements with similar chemical properties and electron structures, they are grouped together in vertical columns called groups. So you can see here on the left-hand side, this is gray. These are metals. So hydrogen, the atomic number is 1. So you can see it increasing. Lithium is at 3, sodium 11, potassium 19, then it's 37, cesium is 55, francium is 87. That's what it means by increasing atomic number. The green, these are alkaline earth metals. Yellow is transitional metals. Other metals are in pink. Non-metals are blue. And noble gases are orange. Notice that there's different colors too. If it's black, it means it's a solid. If it's blue, it means it's a liquid. And if it's red, it means it's a gas. So it's the letters. So for example, hydrogen is in red. Hydrogen is a gas. Let's find a blue one. Mercury is a liquid, because it's in blue. And let's look for one that's a solid. There's lots. Carbon is a solid. So you can see that there are more solids than there are gases or liquids. So just become familiar with some of the more common ones. Here's one with pictures. So for example, batteries will contain lithium. Fruits and vegetables will contain the element potassium. Shells and bones contain the element calcium. Sodium, okay, we know that salt contains the element sodium. So you might buy something and it will say high in sodium. Lead, for example, okay, these were found in weights. Radon, that's an element found in surgical implants. Iodine, you can find in disinfectant. Arsenic, that's an element, it's poison. Aluminum, found on airplanes. Oxygen, the element oxygen is in air. Sulfur, that's why you smell when you make eggs. It's in the egg yolk, has that stinky smell. Helium can be found in balloons. Okay, let's look at some more stuff here. So you can see here that lead, as I mentioned, is a heavy metal, and the symbol for lead is capital P, lowercase b, so Pb. Now, in the past, it was used in things like pipes and paint, but we now know that lead can be harmful to health. That's why it's no longer used in those ways. So you might see on certain items does not contain lead, okay, because we know that it's harmful to our health. Okay, so let's try some of our key questions. So remember, when you're completing your key questions, you don't need to use the internet or Wi-Fi to look up answers. You're doing the key questions because you're reviewing important concepts to prepare you for the culminating. That's if you're choosing to do the key questions. Okay, so let's see how. Oh, actually, we did key questions 44 and 45 already. So key question 46, how many elements exist in nature? So the key word here is nature. So how many, not how many elements in total, but how many elements exist in nature? Key question 47, in your opinion, that means what do you think, why is it so important to have only one set of chemical symbols? Not chemical names, but chemical symbols. So remember, we talked about symbol for carbon is C. So why is that important to have just one set of chemical symbols in the world? If it's an opinion question, you can start off in my opinion. That means it's what you think. Okay, key question 48. Give the names of the elements with the following symbols. So here you're looking at the symbols. And then you will provide the name of the elements. Okay, so that's key questions 46 and 47, and then we'll do this first before we do 48 and 49. So like we said, elements get their symbols based on their names. Most symbols come from the first one or two letters of the element's name. So for example, oxygen begins with O, so the symbol is O. Carbon, the symbol is C. Calcium, capital C, lowercase a. But some symbols come from their names in other languages, like Na for sodium comes from the Latin word natrium. Okay, so it's not SO or S. It's Na because it's from the Latin word natrium. Each element has its unique symbol to make it easy to identify. So we said here oxygen O, carbon C, nitrogen N, hydrogen H. Now the name of an element may begin with a letter that is already the symbol for another element. That's why we use the first two letters. So osmium would be capital O, lowercase s, and then the first letter and some other letter from the name. So instead of CH for chlorine, it's capital C, lowercase l. Calcium, capital C, lowercase a. Helium is HE. Aluminum is AL. And nickel is NI. Okay, so this just shows you how elements get their symbols. Elements get their names in different ways. Some are named after people, like curium for Marie Curie, so CM. Others are named after places like Californium. I bet you guessed that that's California. Some names come from ancient languages, like gold is AU, and that's from the Latin word aurum. Scientists choose names that reflect something special about the element. Okay, so let's look at some here. Lead symbol is PB. For language of origin is Latin, so it's plumbum. Gold we said is AU for Latin aureum. Barium is BA for the Greek origin. Baris, lithium, Li from Greek, lithos. Several elements are named after places or other famous scientists. For example, AM for americum, and ES for Einsteinium. Europeum, EU for Europe. And fermium, FM for Enrico Fermi. He was an Italian physicist. Okay, so that's a bit of a background how elements get their symbols and their names. Now we can do key questions. (48) and 49. So give the names of the elements with the following symbols. So A is Fe. C, you probably already know, that's carbon. O is oxygen. And you can do the rest for key question 48. So find out what Ca and Cl. 49, what are the symbols of the following elements? So for gold, let's try that one. That would be Au. Hydrogen is capital H. So do lead, helium, and uranium. So you can look those up either on the periodic table of elements, or if you just look on pages 20 and 21. Okay, up next. What are compounds and molecules? So earlier I mentioned that there are only 26 letters in the alphabet, but we know using those letters, we know thousands of words, or we can create thousands of words. So a dictionary can even have hundreds of thousands of words. And we know this is done by, words are created by combining letters in many different ways. Okay, just like the way you're reading this page, all the letters or words in here are from the 26 letters in the alphabet. They can be short or long, and most use 2 or more letters. Some words even use the same letter more than once. Now, if we think about that, the same thing about chemical elements, we know there are 118 known elements, but there are millions of different substances. So again, that's possible because most substances are made by combining 2 or more elements, just like we combine 2 or more letters to create words. For example, water, salt, carbon dioxide, baking soda, they all exist because atoms from different elements join together to form something new. Okay, let's look at the word compound. So a compound, you can underline or highlight these terms in your book, is a substance that's made up of atoms. So this is the key thing here. They're joined together. Okay, they're bonded. When elements combine to form a compound, they lose their original properties and the compound has new properties. Compounds don't even have to be in the same state as the elements that they are made from. So for example, you can combine hydrogen and oxygen. Those are both gases. But when they combine, they form water, which is a liquid. So remember we said that H2O is 2 parts hydrogen, 1 part oxygen. So both hydrogen and oxygen are gases, but when you create it by having 2 parts hydrogen, 1 part oxygen, it becomes a liquid. To form a compound, there must at least be 1 metal element and 1 non-metal element. Most compounds occur naturally, but some are created by scientists in labs. Okay, so make sure you remember this. This is always in the culminating activity. The terminology for chemistry. So compound, 2 or more atoms that are joined chemically by a bond. So that means they're bonded or chemically bonded together. They are made from elements on the periodic table. So if you look here, we are looking at another term. This is called a molecule. So a molecule is the smallest piece of a compound that still has all the properties of that compound. So molecules are made up of 2 or more atoms joined together. Some molecules can even contain thousands of atoms. So here's molecules of elements. Helium, hydrogen, you notice there's 2 there, and oxygen, you see 2 of that too. But remember, not all molecules are compounds, because we just showed you that helium, there's only one type. There's only helium there, but it's a molecule. Hydrogen, same thing, it's only made up of hydrogen, but it's still a molecule. And oxygen, same thing. Now, on the bottom part of the slide, these are molecules of compounds. That means it's made up of 2 or more elements. Water, okay, that's H2O. Ammonia, carbon dioxide, okay, CO2. Those are molecules of compounds. So here's a close-up of a water as a liquid compound. So you get a glass of water. It has billions and billions of water molecules. So each molecule is exactly alike. Each molecule has all the properties of water. So the smallest part of a compound is just 1 molecule of that compound. So we take hydrogen, which is an invisible gas element. Oxygen, it's also an invisible gas element, and it can become as water, which is a clear liquid compound. But notice that you need two parts hydrogen and then 1 part oxygen to create water compound. That's why it's H2O. So 1 molecule of water is made up of 2 hydrogen atoms bonded with 1 oxygen atom. So the molecular formula is H2O. So that's how you would write it. Salt, that's table salt. That is a compound made from the elements sodium and chlorine. Now, sodium is a dangerous metal. Chlorine is a poisonous gas. However, when they combine, when you combine them together, they form table salt, which is a compound that our bodies use. So here's how it's written. So 1 part sodium, 1 part chlorine, and you get sodium chloride. So again, you have a dangerous solid element, a deadly gas element, but they're chemically bonded to form sodium chloride, which is a safe white solid compound. Carbon dioxide, this is a gas compound. It's made up of the elements carbon and oxygen. So carbon is a dark solid element, and then you need 2 oxygen, which is invisible gas element, and you get carbon dioxide, which is an invisible gas compound. Now, carbon compounds make up 18% of all the matter in living things. And carbon is also the main source of energy that humans use to survive. Oxygen is the most common chemical element on Earth, and it is one of the main components of air, and it's needed by all plants and animals to survive. So oxygen is a gas that has no color, smell, or taste. When the temperature drops below minus 183 degrees Celsius, oxygen becomes a pale blue liquid. And at around minus 218 degrees Celsius, it turns into a solid. Okay, let's look at what is a chemical formula. So every element has its own chemical symbol, and every compound has its own chemical formula. So let's look at table salt. It shows which elements make up the compound and how many atoms of each element are in one molecule of that compound. So the formula for table salt is NaCl. So Na is a symbol for sodium, Cl is a symbol for chlorine. So one molecule of NaCl has a total of 2 atoms, meaning that you have one atom is a sodium and the other atom is chlorine. Sometimes a symbol has a small number written next to it. Now that number tells us the number of atoms there are of that element. So here's a picture of Na plus Cl. So Na, you don't see a number beside it because it just means there's only one element or one atom. Cl2, so Cl is chlorine, but the number 2, that means there's 2 of those. So here's 1, and then you have 2 of chlorine. So if you add them together, you have 3 atoms of that element. Okay, let's look at another one. Okay, this is the most popular one, water. So you have H is a symbol for hydrogen, O is a symbol for oxygen. H2 means 2 atoms of hydrogen. So remember, you see the number, that's the subscript, the small number beside the element. That shows us that there are 2 hydrogen atoms. So one molecule of H2O then has a total of 3 atoms. So you count it, you just go 1, 2, 3. The formula for a compound never changes. So if you're creating water, it always has to have 2 parts hydrogen, 1 part oxygen. If the formula changes, then that means a new substance has been created. So it's a good idea to learn some common chemical symbols, but if you see one you don't recognize, you could always look it up online, or if you have a chemistry book, you can look it up. Okay, let's look at some more common molecules. The first one is mercuric oxide. This is a bright red or orange powder made from the element mercury and is combined with oxygen. When it is heated, it breaks down into mercury and oxygen gas. Now, in the past, it was sometimes used in batteries or as medicine, but because mercury is toxic, its use is now very limited. So looking at that, the name is mercuric oxide, elements mercury Hg and oxygen is O. So 1 atom of mercury, 1 atom of oxygen, that means you have a total of 2 atoms. Next up is potassium chloride. Okay, the formula name for, or symbol for potassium chloride is KCl. Elements are potassium, which is K, chlorine, which is Cl. Number of atoms in each element, just 1 of each. So 1 potassium, 1 chlorine. The total number of atoms in one molecule are 2. So potassium chloride is a chemical. It's a white, salty powder and is often used as substitute for table salt in low sodium diets. Potassium chloride is also used in fertilizers to help plants grow because potassium is an important nutrient for them. Okay, so that's just an everyday use for potassium chloride. The formula name for sodium hydroxide, also known as Li, is NaOH. So Na is sodium, O is oxygen, and H is hydrogen. So notice no numbers beside each element, so that means it's just 1 of each. So 1 atom of sodium, 1 atom of oxygen, 1 atom of hydrogen. You have a total of 3 atoms total. So Li is strong white solid chemical made from sodium and hydroxide, and it's used in many everyday products. You might see them in cleaning products, drain cleaners, soap. It can break down grease and oils. That's why it's useful for cleaning. However, it is very caustic, which means it can burn skin, so it should be handled carefully. Some more common molecules, Fe2O3, also known as iron oxide or rust. So iron is Fe, oxygen is O. Notice the numbers, the small numbers beside the element. That means to create iron oxide, you need 2 atoms of iron and 3 atoms of oxygen. So the total number of atoms in one molecule, you just add them up. So 2 plus 3 equals 5 total. So iron oxide, like I said, is commonly known as rust, which forms when iron reacts with water and air. So iron oxide can be red, can be brown or orange, depending on the type. In everyday life, you can see it on old rusty metal objects. So if you leave your screwdriver outside and you find it later, you'll notice that it has rusted. Also on rusty metal objects like bikes or cars. Iron oxide is also used in pigments for coloring paints, ceramics, and even makeup. And the last one we'll do today is sulfuric acid. Now this is a strong, colorless liquid made from sulfur, oxygen, and hydrogen. It is used in many everyday products like car batteries to help store energy. It's also used in making fertilizers, cleaning products, and in some types of drain cleaners because it can break down substances. Now sulfuric acid is very corrosive, meaning it can burn your skin, so it should be handled carefully. So here's the formula for sulfuric acid is H2SO4. So H stands for hydrogen, so the number 2 is there, so that means there's 2 atoms of hydrogen. S is sulfur. You don't see a number, so that means there's 1 atom of sulfur. And then O stands for oxygen, and you see the number 4, so you have 4 atoms of oxygen. So if you add it, you have 2 plus 1 plus 4, you have a total of 7 atoms, okay, in a molecule of sulfuric acid. So again, it's used for fertilizers, detergents, paint and pigments, plastics, okay, and other uses like explosives, pesticides, dyes, and could also be used in batteries. Okay, so that's it for today, and we will continue on Wednesday. Miigwech.